Hi students, now we are going to solve the problem number 8. Starting from a stationary position, Rahul pedals his cycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. It is a very simple and interesting question. The problem is giving two situations. In the first situation, Rahul starts his bicycle from a stationary. Stationary position means he is initially at rest. So we will divide this problem into two steps. So first he is pedaling his cycle from A to B. So initially he is in a stationary position. That means he is at rest. So at rest means what is his initial velocity, you tell me? Yes, 0. Understand? So here his velocity is 0 meter per second. And then he is pedaling his cycle to attain a velocity of 6 meter per second to reach the point B. So he starts from A with a 0 velocity. He reaches B with a final velocity 6 meter per second. And the time taken is 30 seconds. So the first step 1, I will take from the position A to the position B. So initially he is starting from A, reaches B. So the initial velocity is equal to 0 because he is initially at a stationary position. Then at B his final velocity is equal to 6 meters per second and the time taken for his journey from A to B is 30 seconds. Okay. So in this case let us take the acceleration is A1. So I will take acceleration A, okay, 1, and that is equal to V minus U divided by T. If you want, you can call this as U1, this is V1 and this is T1. So V1 minus U1 by T1 is equal to A1. Okay. So I am going to substitute. Therefore A1 is now equal to V1 is 6. So this is 6 minus U1 is 0 divided by the time T1 is 30 seconds. So this is 30. So this is equal to 6 minus 0, 6 by 30. 6 5s are 30, is it not? So this can also be written as what? 1 by 5. So 1 by 5. Therefore A1 acceleration is equal to 1 by 5 is 0.2 meters per second square. So his acceleration from A up to the point B is equal to 0.2 meters per second square. Have you understood this? Okay, what is happening next? After reaching B, he applies the brakes. And when brakes are applied, the velocity will decrease. Here his velocity decreases from 6 meter per second to 4 meter per second. And for this change in velocity, how much time is consumed? 5 seconds. So step number 2, I will write from B up to C. Okay, from B to C. So in this case, the velocity at the point B is the initial velocity. So I will take it as U2. So from the point B up to the point C means B is the initial point. And the velocity at B is equal to how much? 6 meters per second. And the final velocity here V or V2 at this point C is equal to 4 meters per second. Okay, 4 meters per second. And this change in velocity takes place at a time T2 is equal to 5 seconds. Is it not? Now the velocity decreases. So the acceleration a2 I will take. In this case, the acceleration, okay, from B to C is taken as a2. So a2 is equal to v2 minus u2 divided by t2. So a2 is now equal to 4 minus 6. So final velocity 4 minus initial velocity 6 divided by the time taken is 5 seconds. So that this is equal to 4 minus 6 is minus 2. Take care of the symbols, okay, and the signs. So the sign is negative. So this is minus 2 divided by 5, and this is equal to minus of 0.4. Therefore, the acceleration a2 is equal to minus 0.4 meters per second square. Okay, can you tell me what is the other name for the negative acceleration? Yes, it is retardation or deceleration. Therefore, retardation, okay, retardation is now equal to 0.4 meters per second square. When you write retardation, don't write the negative symbol. Retardation means it is understood negative acceleration. So the acceleration is negative and it is minus 0.4 meters per second square. So they have asked you to calculate the acceleration of the bicycle in both the cases. So in case 1, what is the acceleration? It is plus 0.2 meter per second square. In case 2, what is the acceleration? It is minus 0.4 meters per second square. I hope you must have understood well. Fine.